Hello friends, today we are going to start with projectile motion. Now what is a projectile? So for explaining that I'll give you an example first and then we will discuss what is a projectile. Okay, now example is you are standing on this football ground here. This is the goal post and the ball is here. Okay, and you want to make the ball land in the goal post. That is your goal, isn't it? So you hit the ball, you kick the ball from here, let us say point O here, and it lands in the goal post at point A here. Correct. Now, how does the ball move? Initially, it has been given some speed in this direction. Okay, and then it moves, it keeps on moving, it reaches some maximum height, and finally, it again reaches ground here. Correct. So, you are on ground here and ground here. Now, while it was in motion, was any other force acting on it? The answer is yes, it was. It was gravitational force of attraction. But then, apart from gravity, was any other force acting? No. Okay. Now, again, you would say there might have been air resistance, but I'm going to ignore air resistance here. Okay. So, you must have been able to make out that I'm setting or applying some conditions. Now my first condition is that once the ball is airborne, there is no other force acting on the ball except gravity. Correct. The air resistance remains same, or air resistance remains, I would say, negligible. Okay. Number 3, the acceleration due to gravity at all the places, okay, that is same. Okay, whether the ball is here or here or here or then here, the acceleration due to gravity remains same throughout. And any other approximation or assumption that you might think of? Maybe I would think of radius of curvature of earth. Correct. Earth is round, right? It is not flat. Some people believe that earth is flat, but then that is not the fact. Okay, we all know that earth is round, and then but then we know that earth is round, but then here we are not going to consider that. Okay, we are going to consider that this surface is smooth, and it is, isn't it? This goalpost, distance between the point where I am kicking the ball and the goalpost, what is the distance? It is negligible compared to circumference of earth. So obviously I am going to ignore the curvature of earth. That is not any other thing that you could think about. Yes, I could think of the speed of rotation of earth. Correct. Earth is rotating about its own axis, but then we are going to ignore that because it is going to be a negligibly small variation over there. Correct. And now I'm calling this ball which I'm kicking, I'm calling it a projectile. Okay, so then what is a projectile? Projectile is a body which has been given some energy initially, and once it is airborne, it moves completely under the influence of gravity with no other force acting on it. Right? Okay. And then what are the conditions? Let me list down the conditions which I said some time back. Number 1 is no other force except gravity acts. Number 2, negligible air resistance or then 0. Number 3, value of G remains same throughout. And number 4, effect of, or I would say no effect of rotation of Earth. Okay, now these are the assumptions with reference to what? An object thrown with some initial velocity. Okay, an object thrown with some initial velocity, and then adhering to these conditions, okay, it moves, okay, it reaches some maximum height, and then it reaches ground again, okay, that object would be called a projectile. Now, path of this projectile, path from O to B to A, okay, this path, that path of projectile, it is called trajectory of the projectile, correct. Now up to here it may be clear. Now one more thing which is worth noting is there any acceleration acting on the body in the horizontal direction? We know that the gravitational acceleration is acting vertically downwards. Is there any force or any acceleration acting in the horizontal direction? No. So when there is no acceleration in a particular direction, the motion in that direction would be uniform, isn't it? So if there is no acceleration in the horizontal direction, I would say AH. If AH is equal to 0, then my motion in the horizontal direction would remain, it would be uniform motion, or the velocity would remain uniform in the horizontal direction, correct. Let us again give little thought on that. Okay, now just come back to our this football. Now I have given it some initial velocity, let us call that velocity u, okay. And okay, now this velocity u, is it horizontal? No. Is it vertical? No. It may be vertical, I don't know, I don't want to say anything about that now, but then it may be, it is definitely not horizontal here, and so that means it is making some angle with the horizontal here, that is theta, correct. Now as the ball moves here and it reaches over here, it reaches some maximum height, naturally, something that you throw upward, okay, it will not, it won't keep on moving upward forever, okay, gravity is going to pull it down, right. So at some point of time its vertical velocity, which was, my upward velocity, is going to reduce to 0, and then because of my downward acceleration due to gravity, it is going to start coming down, and my velocity in the downward direction will go on increasing, and finally it will fall on the ground, correct. So that is something that we all know, okay. Now in this case, okay, this velocity u, I can resolve it into vertical and horizontal components, okay. And now since there is no horizontal acceleration acting on this body, on this ball, its horizontal velocity, which I am going to call ux here, it is going to remain constant, okay, and vertical velocity will change, okay. So uy, okay, it is going to change, and that is the reason why my vertical velocity over here, it becomes 0, okay, but horizontal velocity still remains same, correct. And with that velocity, now it starts moving further, right. And from the maximum height, then downward velocity will keep on increasing, and finally my projectile will land on the ground, right. So that is the basic logic behind this. This was just an introduction to projectile motion. In the next video, we are going to talk more about you know, these changes in velocity, okay, the maximum distance that the projectile covers, the maximum height it reaches, or maybe the time taken to reach the maximum height, time taken to uh, reach ground from the maximum height, or then total time taken for the flight. Okay, all those things we'll be seeing in the next video. Thank you so much.